Okay, pre-cal students, in this video we are going to apply some of the information we have learned in trigonometry to some different word problems. So here we go. Your heading today is Word Problems Lesson 9.3, so please write that in your notes. Word Problems Lesson 9.3, and be sure to include the date with your heading. Okay, moving on. Go ahead and turn your books, if you would please, to page 569, example number 5. 569, example number 5. I'm going to move on. If you need to pause the video, feel free to do that. If you'll look on this page, example number 5, page 569, you're going to see they give you a picture already of the situation. Now, I'm not a big fan on your tests this year. I'm not a huge fan of giving you pictures, so really you're going to have to learn to draw your own drawings or sketches on your own. However, I will say this, when you draw them, I would use points, lines, points. I would not get as fancy as they have gotten in their drawing, because you really want to be able to draw triangles and angles and stuff like that. And so that's a little advice I give you. So we're going to go ahead and draw our own drawing here. And the word problem reads as follows. A surveyor is standing 115 feet from the base of the Washington Monument, as shown in the picture to the left there. The surveyor measures the angle of elevation to the top of the monument and sees that it's 78.3 degrees. How tall is the Washington Monument? Now, let's take care of this phrase, angle of elevation, okay? Excuse me. Anytime you hear the phrase angle of elevation, you first of all know you're going to have a horizontal line, and then you're going to have a line going up. And this angle here will be your angle of elevation. Okay? If we had an angle of elevation of 85 degrees, you would simply draw a line here and then draw a line going up approximately 85 degrees. That's called an angle of elevation because this line here is elevating. It is going upward. And by the way, while we're talking on this topic, you might want to take some notes. If you hear the phrase angle of not elevation, but angle of depression, that is not talking about an angle that is sad, okay? It's talking about depression going downward. So an angle of depression would look like this. You would draw a horizontal line, and then you would draw an angle or a line going downward, and this would be your angle of depression, okay? So if I said we had an angle of depression of 25 degrees, you would draw a horizontal line, and then it really doesn't matter where you draw the angle. You could draw it from here or here, and 25 degrees would be approximately that right there. So right here would be your angle of depression. So please understand the difference between angle of depression and angle of elevation. And with that in mind, let's go ahead and continue on. So it says the surveyor is standing 115 feet from the base of the Washington Monument. So here's the Washington Monument. Again, I'm not going to try to get all pretty in my drawings. Here's the Washington Monument, and here's the ground, okay? Now, we're going to go ahead and put you right here. And again, you could draw a stick figure if you wanted to, but I'm not really a fan of that because I'm trying to get points and lines so I can use triangles. So I'm going to say that you're standing right here, and we know the distance from this point here to this point here is 115 feet. And I'm not too worried if my drawing is drawn to scale. That's not a big deal. The surveyor measures the angle of elevation to the top of the monument. So, angle of elevation, that means you have to draw a horizontal line right here. Here's your horizontal line. And then draw an angle going upward toward the monument. So here's your angle of elevation going upward right here. And the surveyor measures this angle of elevation right here as being 78.3. So not too hard so far. We're just filling in information. Now, let's see, what else does it tell us? I think that's it. And the question is, how tall is the Washington Monument? Now, you think about this for a second. All that the surveyor had to do was measure how far he was away from the Washington Monument, and then with a device, he could measure the angle of elevation to the top of the monument, and now he can find the height. We'll call it X. He can find the height right here of the Washington Monument. Now, obviously, we're dealing with the right angle right here, okay? And so with that in mind, we have this side over here as my hypotenuse, Here's the angle I'm dealing with, so I'm going to go straight across. This is my opposite side, and this would be my adjacent side. Now, think about this. I know the measurement of the adjacent side is 115. I know that. So I want to use that. And I'm looking for this side over here, which is my opposite side. So which trig function uses adjacent and opposite? Well, it's tangent or cotangent. We're going to use our regular trig function, sine, cosine, or tangent. So we're going to use tangent. So watch what I can do. I can set up an equation here. The tangent of this angle, 78.3, equals opposite, which is x, over adjacent, which is 115. Now, from your algebra training, you should know what to do. We have a denominator of 115, so we're going to multiply both sides of the equation by 115. If you multiply the left side by 115, you will get 115 tangent 78.3. Let me fix my decimal there. It's in the wrong place. 78.3. And if you multiply the right side by 115, think about it. You would have x. You would have x over 115 times 115 over 1. They would cancel, and you're just left with x. So now you know what x equals. X equals 115 times the tangent of 78.3 degrees. Now, make sure your calculator's in degrees. Mine right now is in radians. So I'm going to scroll down and make sure my calculator's in degrees. And now I'm going to type into my calculator 115 tangent 78.3. And if you type that in correctly, you're going to get 555.3139955. So I'm going to round that to the nearest foot. And I'm going to say the Washington Monument is approximately 555 feet tall. Okay? Pretty cool word problem. Just applying what we've learned with our trigonometry so far. Okay, 2 more word problems, and then you'll have some homework to work on these types of problems. We're still on page 569. We're looking now at example number 6. Number 6 reads as follows. You are 200 yards from a river. Rather than walking directly to the river, you walk 400 yards along a straight path to the river's edge. Find the acute angle between the path that you just walked and the river's edge. So here we go. Pretend you do not have a picture there in front of you. So I guess if you wanted to be fancy, you could draw a river like this. I'm just going to simply draw a straight line. There's my river, okay? And then we're going to say that you are right here, and you are 200 yards from the river. So I'm going to go ahead and label this 200 yards. And then the problem says, instead of walking directly to the river, you walked in a straight line 400 yards to the river's edge. Now, if you walked 400 yards, obviously you're going to have to walk diagonal. So you walked 400 yards diagonal to the river, okay? Not the best drawing, but you get the idea. So there we go. So we're going to label this 400 yards, okay? Grab this, drag it over just a little bit so it looks a little better, and slide that in, and there we go. So we've really not done anything that's earth-shattering. We know that you were here. You were 200 yards away from the river, so 200 yards. And you know that you walked in a straight line to the river, and you walked 400 yards. Why I put degrees there, I'm not sure, but it should not be degrees. And so what they ask us to do now, we'll put yards here real quick. What they ask us to do is to find the acute angle between the path that you just walked and the river's edge. Well, here's the path that you just walked. Here's the river's edge. So here's the acute angle right there. So that's the angle you're looking for. So with that in mind, we're going to call this angle X. Now, let's think about this. Here's the angle you're dealing with. We know that we have a right triangle, okay? And if this is the angle we're dealing with, if we go straight across, this is my opposite side, and this is my hypotenuse. So the two sides that I know would be my opposite side and my hypotenuse. Now, which trig function uses opposite and hypotenuse? Well, that's sine, okay? So I'm going to write down the sine of x, that's my angle right here, equals opposite over hypotenuse, which is 400. And now, students, we have learned whenever you're missing the angle and you're looking for the angle, you type in the inverse sine button, and when you do, this should pop up on your screen, okay? And we are in degrees. And then you type in 200 divided by 400, or you could type in 1/2 if you wanted to, because when you reduce 200 over 400, you get 1/2. But either way, you will get 30 degrees. So you would have 200 divided by 400, hit enter, and you will get 30 degrees. So now you know that angle. Just simply knowing the distance from here to here was 200, and knowing the distance from here to here was 400, you then could find this angle right here using sine. Okay? Pretty cool. One more problem and we're finished. Please turn over to page 570, example number 7. Page 570, example number 7. Specifications for a loading dock ramp require a rise of 1 foot for each 3 feet of horizontal length. Now what that means is every time you go across 3 feet, you're going to have to go up 1 feet. So let's say from here to here we had 3 feet, and then from here to here we had 3 feet, and from here to here we had 3 feet. Then we had better go up. There's 1 foot, there's 2 foot, and there's 3 foot. And of course they have these specifications so that the ramp is not too steep or not steep enough. And so let's go ahead and read on. The ramp requires a rise of 1 foot for each 3 feet of horizontal length. Then they give you this drawing here, which I'm going to have to give you in your notes. So here it is. And it says in figure 9.28, which is this figure right here in front of you on the screen, find the lengths of B and C. Here's B, here's C. Find the lengths of B and C and the measure of theta. And here's theta right here. Now if you look in your book, you'll see they give you this length right here as 4. Now students, come on, you're in pre-cal, you're smart students, you can figure this out. Remember, it says in the original problem, for every 3 feet of length, you have to have 1 foot of rise or height. Well, we have 4 feet. 1, 2, 3, 4. And remember, for every 1 foot over here, you have to have 3 foot over here, or 3 feet over here. So if I have 1 foot over here, that's 3 here. If I have 1 foot here, that's 3 more here. If I have 1 foot here, that's 3 more here. If I have 1 foot here, it's 3 more here. So obviously B has to equal 12. 3, 6, 9, 12. Now very quickly, if that confuses you, then use ratios. Remember the original problem said you have to have a rise over run of 1/3. And then of course your rise over here is 4. And so your rise would go up top with your 1. So here's your rise of 1, your run of 3. Here's your rise of 4 and your run of x. That's what you're looking for right here. I guess you could put a b there. And now go ahead and cross multiply. 1 times b is b, and 3 times 4 is 12. Either way, you get 12. So that wasn't too difficult. And now to be honest with you, to find c, that's just Pythagorean's theorem. We can do this very quickly. Leg squared plus leg squared equals hypotenuse squared. So one leg is 12, the other leg is 4, the hypotenuse is c. 12 squared is 144, 4 squared is 16. If you add those together, you will get 160. And if you take the square root of both sides, you will get 12.65 feet approximately. So there we go. Now we found the length of C. So in the problem so far, it asked us to find the length of B. We've done that. We were also asked to find the length of C. We've done that. And now we're going to find the measurement of theta. Now I would like to appeal to your common sense, okay? Notice in this triangle we know all three sides, okay? We know the length of this side, and this side. But are not decimals harder to work with? Now don't get me wrong, you're welcome to use C 12.65 for one of your sides. That's totally fine. But I'm not going to. I'm going to use the easier two numbers. Now I'm going to say that again. You can use any of these two sides that you want to find the measure of theta, okay? But I'm going to use the easier sides. I'm going to use this side here, 12, and this side here, 4. And I'm going to find the measure of this angle. So if this is the angle I'm dealing with, go straight across. This is your opposite side. This is your hypotenuse. And this is your adjacent. So the two sides I'm dealing with are opposite and adjacent. So I'm going to write a trig equation. Tangent of theta equals opposite over adjacent. And now look, we're looking for an angle, so you would hit inverse tangent. That's tangent to the -1 on your calculator, and then type in 4 divided by 12 or 1/3 if you want to. Hit enter, and you will get out approximately 18.43 degrees. Okay? And so there is the answer to theta, 18.43 degrees. All right? Put that right up here in your triangle, and there we go. Okay? So you should be able now to read a word problem, draw a right triangle that represents the situation accurately, and then fill in the given numbers, lengths, measurements, and then find the unknowns using sine, cosine, and tangent. Okay? Call or email if you have any questions.